Hello everyone, this is Gianni from Virginia, and I'm here to show you my entry for the Psoc5 design contest. It's called a drum tuner, and it tunes drums. I've got myself here a drum, and I've had a couple of days to play around this circuit, so let me show you what I got. In this segment, I will introduce the capabilities of the drum tuner for the Psoc5 design contest. Here we have the Psoc5 development board, and on it I've attached a microphone and a preamplifier. The output of the preamplifier is attached to an analog pin on the Psoc5. This will serve as the input to the FFT and other calculations. The LCD readout indicates to the user the target frequency for tuning the drum, as well as the most recent sampling and calculated fundamental frequency. There are two LEDs mounted on this periphery board, which indicate to the user whether to tighten or to loosen the drums. In addition, there are two buttons on the circuit. The left button allows the user to cycle through the target frequencies. The right button allows the user to manually trigger an FFT calculation. In addition, there is an impulse detection circuit within the Psoc5 made using a voltage comparator that will detect any loud noises within the vicinity of the microphone. This will automatically trigger a series of A to D conversion samples and an FFT calculation. Now let's play around with the FFT capabilities of this circuit. We can test the accuracy of the FFT by calculating the fundamental frequency of a set of known tones. I will demonstrate this by generating a 220 Hz tone, then using the right button to trigger a set of A to D conversions followed by an FFT calculation. As you can see, the circuit has indicated that the tone was at 219.98 Hz, which is pretty accurate. Let's try that again with a G note at 196 Hz. Again, the measured frequency was accurate at 195.89 Hz. We can also test the impulse detection circuit by creating a loud sound next to the microphone. When this happens, the LED next to the left button will light up, indicating to the user that an A to D sample and an FFT calculation has taken place. I will first demonstrate this by doing a clap. As you can see, the light has lighted up and it has measured my clap. We can also do this by trigger this with a drum tap. Here the drum tap was at 200.77 Hz. Now let's play some drums. I will now demonstrate how a user might use the LED indicators to tune his or her drum. We can do this by first taking an initial reading and seeing how far away we are from the target frequency. As you can see, the LED has indicated that we are at 188.60 Hz. The bottom LED has started to blink at a very fast rate, indicating that we are quite far away from the target frequency. I will tighten the muffler on the drum, which will increase the frequency of the drumhead slightly. As you can see, the frequency has increased to 190 Hz, and the LED has slowed down slightly, indicating to the user that they are slightly closer to the target frequency. I've tightened the muffler a little bit more, and we are a little bit closer to the target frequency. Now we are within 1 Hz of the target frequency. When this happens, both LEDs will be in a solid on state. This indicates to the user that the drum is within the tuning range, as indicated by the target. If I tighten the drum even more, the bottom LED will turn off and the top LED will start blinking, indicating to the user that the target is below the current frequency of the drum. As you can see, we are at 199.96 Hz, and the top LED has started to blink. Now we are over 200 Hz, and the top LED has started to blink even faster. The speed of the blinking LED indicates to the user how far or how close he or she is to the target frequency. This is how a user might use the circuit to tune his or her drum. The only thing left to do is to tune the drum, so let me show you how it's done. I'm going to use the LED indicators as well as the LCD display to help me tune this drum to the target frequency of 195 Hz. First, I'm going to tap the drum to see where it's at. The LCD shows that the drum is vibrating at 186 Hz. In addition, the lower fast blinking LED tells the user that the drum is quite far away from the target. I'm going to use a drum turning key to tighten the drum head 180 degrees to the right. This particular drum is a snare drum, but the drum tuner will work with any drum with an adjustable drum head. Let's tap again to see where we're at. You can hear the slight increase in the vibration frequency of the drum head. The LCD shows that our drum is now vibrating at 193 Hz. The LED has also slowed down in its blinking, indicating to the user that they are slightly closer to the target. I'm going to tighten another quarter of a revolution to the right. And the last one. Let's tap again. Again, there's a noticeable increase in the frequency of the vibration of the drum head. Both LEDs are now on a solid on state, indicating to the user that the drum head is within 1 Hz of the target frequency. And indeed, our LCD indicates that we are at 195.6 Hz. So there you have it. I've tuned the drum. To complete the tuning, I've tuned the other side of the drum, and I've attached the snare to the bottom side. All that's left to do is to tighten the snares, flip the drum around, and this snare drum is ready to go. Nice snap, eh?